Hello there again. Today we'll be looking at lesson 7 in module 1, which is comparing ratios with tables. All we're going to be doing is we're going to be looking at things like these tables here and trying to figure out different information based on the ratios in those tables. Like, for instance, in the one we're going to do today, which restaurant has the strongest iced coffee. But getting ahead of ourselves. The question that we will seek to be able to answer at the end of this lesson is, how can I use tables to compare ratios? So let's jump right in. There are 3 ways to do this. So our task is broken down into 3 different techniques. Step number 1, or option number 1, is we can find matching values in matching columns. We'll get to that in just a second. Option number 2, if we can't find these matching values in matching columns, we need to expand the tables until the values match. And we can talk a little bit about that in a little bit, and exactly what it means to expand the tables. And lastly, what we'll learn how to do most of the time in the future, but we're getting a little teaser or taste of it right now, is how to find the ratio's value for each table. So let's jump right in. Example number 1. These tables show the amount of ice per coffee at each coffee shop. So I used to work at Dunkin' Donuts, and every morning we would make a huge batch of iced coffee. We would pour some coffee in there, and then we would pour some ice cubes in there, and inside we'd have all this stuff. Obviously, the more ice you put in, the less strong the coffee will be. So we're trying to figure out who's got the strongest coffee in the neighborhood. Okay? We have Dunkin' Donuts, we have Starbucks, and we have Dutch Bros. So for every 2 cups of ice at Dunkin' Donuts, we have 6 cups of coffee. For every 3 cups of ice, we have 9 cups of coffee. For every 5 cups of ice, we have 15 cups of coffee, and so on and so on. Same thing at Starbucks. For every 1 cup of ice, we have 2 cups of coffee. At Dutch Bros, for every 3 cups of ice, we have 12 cups of coffee. Now, that's all well and good and makes sense, but the question is, who has the strongest iced coffee? People like me and maybe like you, we don't like to put a lot of extra cream and sugar and all that jazz. We just want the coffee the way that it's supposed to be. So we're looking for who's got the strongest stuff. Option number 1 is we can find matching values in matching columns. So if you think back to yesterday's lesson, we talked about the x value being the first number and the y value being the second number. So what we'll do is we'll stick in the x column. We got to stick in the x column, and we'll compare these values. Once we find values that match in matching columns, we can begin to compare. So I have a 1 and a 2. They don't match. I have a 3 and a 3. Oh, those match. So at Dunkin' Donuts, if we put 3 cups of ice, we put 9 cups of coffee. At Starbucks, if we put 3 cups of ice, we use 6 cups of coffee. So obviously, Dunkin' Donuts, if we're just comparing Dunkin' Donuts and Starbucks, Dunkin' Donuts would be stronger because 9 is bigger than 6, right? Okay, so we know Dunkin' Donuts is stronger than Starbucks. Let's take a look at Dutch Bros. We've got a 2 and a 3. Those don't match. We've got a 3 and a 5. Those don't match. Well, actually, we have a 3 here, and then we have a 3 here. Okay, well, let's take a look at this. Whoops, I'll do one of these. Let's take a look at this ratio and this ratio. At Dunkin' Donuts, if you have 3 cups of ice, they put in 9 cups of coffee. At Dutch Bros, if they have 3 cups of ice, they put in 12 cups of coffee. So you know as well as I do that if we're looking at Dunkin' Donuts and Dutch Bros, and we're looking at 3 to 12, and 3 to 9, because the 3's match, the 12 is bigger than the 9. So Dutch Bros has the strongest coffee. Now, there's another way we could have done that. If we had been more patient, we would see that in our X column, we've got 2, 1, 3, 4, 8, 8 and 8 match. Okay, well, let's see if we can find an 8 over here. All right, well, we've got an 8 there. So if we just look straight across this bottom, we've got 3 sets of ratios, and we can compare them pretty easily, right? All we have to do is compare the 24, the 16, and the 32, because all of these 8s match. So we know right off the bat that 32 is the biggest, so they are number 1. We know that 24 is the second biggest, so they are number 2. And 16 from Starbucks is number 3. Just like that. Now, before I go any further, I do need to make sure that I tell you, in case any of you guys have family that works at those restaurants, that these numbers are completely made up and none of it is true. It's just as an example. So if we wanted to answer this question, we would say that Dutch Bros has the strongest coffee. Great. Now, I am most partial to just coffee made at home. Number 1, because it's cheaper. Number 2, I just like it better. So, anyway, that's how we do task number 1. Now, task number 2 is a little bit different, but very, very similar. Here's an explanation for task number 1. There is an 8 in the ice column, so 8, 8, and 8 for each of the restaurants, Dunkin' Donuts, Starbucks, and Dutch Bros. And Dutch Bros has the most coffee per ice. So they have 32, which is the most, 32 cups, which is the most amount of ice the most amount of coffee per 8 cups of ice. So we looked straight across, just a reminder, we looked straight across this bottom ratio because the 8s matched and 32 was the largest. All right, let's move on to task number 2, expand the tables. We don't have to expand the tables because these values match. 8 matches, 8 matches, 8 matches. What we can do in a scenario where they don't match, for instance. So, last but not least, we have our third approach. Find the ratio's value for each table. Now, obviously, each table holds a bunch of different ratios, right? And there's 4 ratios in each table. 1, 2, 3, 4. Okay. But each of those ratios has the same value because they're all equivalent, correct? So if you remember, when we're trying to find the value of a ratio, it's as simple as turning that ratio into a fraction. So for our first example, we have 2 to 6. If you turn 2 to 6 into a fraction, we have 2/6. Okay? Now here, for Starbucks, our ratio is 1 to 2. And if you turn 1 to 2 into a fraction, it's just 1/2. And lastly, here we've got our Dutch Bros coffee, 3 to 12. And if you turn 3 to 12 into a fraction, you get 3/12. Okay? So that's what we're looking at right now. So 2/6 we know is not simplified. We simplify it by dividing top and the bottom by 2. So 2 over 2. And 2/6 divided by 2 over 2 is 1/3. So 1/3 is our final value down here. Then we've got 1/2, which is already simplified. So 1 to 2. And then 3/12 is not simplified. We must divide it by 3 over 3. And that gives us 1/4. 3 divided by 3 is 1. 12 divided by 3 is 4, giving us a value of 1/4. So we can think of this as, remember, our X value is our ice. So 1 cup of ice, 1 cup of ice, 1 cup of ice. Now we can compare these. So every time you are filling up a bucket with coffee, ice, every time at Dunkin' Donuts, when they put 1 cup of ice in, they put 3 cups of coffee. At Starbucks, for every 1 cup of ice, they put 2 cups of coffee. And at Dutch Bros, for every 1 cup of ice, they put 4 cups of coffee. So 3, 2, and 4. 4 is the biggest. Therefore, Dutch Bros is our strongest coffee. Now, just to recap, we learned how to compare ratios using tables. Step 1, just check the columns for matching values and then compare the corresponding value. So check the x's to see if any of the x's match and look at the y's. You could also check the y's, and if any of the y's match, you check their x. Or sometimes, if these don't match anywhere along the way, you will have to fill in more info on the tables by expanding the tables. But we were fortunate enough that these tables had all the information we needed. And then lastly, you can use the value of the ratios to compare. So 1 to 3, 1 to 2, 1 to 4, 4 is the biggest, so it's the strongest. Hope that helps. Bye. Let's take a look at, I'll just kind of make one up here. We've got a table here, we've got a table here, and let's say we've got, let's say just 2 to 5, and then we've got 4 to 10, 6 to 15, and then over here, let's go with 1 to 3, 2 to 6, 3 to 9, and 5 to 15. So, if you're looking across each of these columns, I guess we have a 2. I probably could have picked a better example. Let me try something real quick. Sorry. Try another one. So we've got 2 to 5, 4 to 10, 6 to 15. Okay, we'll do that. Then we've got 1 to 3, 3 to 9, and we'll go 5 to 15. So if we're looking at these, none of the x values match. 2 doesn't match any of those, 4 doesn't match any of those, and 6 doesn't match any of those. So what we can do is we can expand the table by filling in some of these missing numbers, right? So we jump from 1 straight to 3 and then straight to 5. There's a 2 missing in here, and there's a 4 missing in here. Okay, so if we can fill in this 2, we might just be able to compare it to this 2. So let's figure out what we are adding by. So if we are getting from 1 to 3, we're adding 2. So, and in that same jump from 3 to 9, we're adding 6. So if I cut this 2 in half, it becomes 1, and I cut this 6 in half, it becomes 3. So really, for every 1 that I add over here, I'm adding 3 over here. So if I were to put a ratio in this spot, that ratio would be 1 plus 1, which is 2, and 3 plus 3, which is 6. So my ratio, if I were to extend this table, I'd have 2 to 6, and here I have a value that matches 2 and 2. So if I'm looking at these 2's and I'm looking at their partners, In the Y column, I see a 5 and I see a 6, and the 6 is bigger, so I know that this ratio is larger. Okay, so that's what I mean by expanding the table.